Alright, this is our last application example, example 7, all about max and min problems that we didn't get to in class. And here's kind of the situation. We have a rectangular page that contains 24 square inches of print. So let's draw a picture here, a rectangular page. Okay, so a piece of paper. It has 24 square inches of print. So imagine how a piece of paper works, how you have you print it out as a Word document and you have margins. So here's my printed out words. Imagine all my sentences here. And it says the margins at the top and bottom must be 1.5 inches. So top and bottom, so like up here I have a little margin of 1.5 inches. And same on the bottom, down here, 1.5 inches. And then it says, and left and right margins must be 1 inch. So from here to here is a little smaller, it's only 1 inch. And here to here is also 1 inch. So there's our bottom margins. What should the dimensions of the page be so that the least amount of paper is used? Okay, least amount of paper. Least clues me in, I want a minimum. So we're doing a minimum sign chart. So first things first, we need variables. Let's say the paper, the written piece, has a dimension of x, and the written piece on the bottom has a dimension of y. You can use any variables you want, but x and y kind of makes it easy. The area of the print of the words is going to equal x times y. And according to this, the rectangular page is to contain 24 square inches of print. So this whole thing equals 24 inches squared. So there's some facts that we have right there. We also can figure out the area of the entire paper. The dimensions of the entire paper, if we did the side times the bottom, it's going to be x plus 1.5 plus 1.5. 1.5, 1.5 together is 3. So x plus 3 would be the length. And the width on the bottom is going to be y plus an inch, and an inch makes 2 inches on the margin. So y plus 2. X plus 3 and y plus 2. Here's what we're working with. It says, what should the dimensions of the page be so that it's the least amount of paper used? We are trying to minimize the area of the paper. So this is the formula I will be deriving. But there's two variables and we need to eliminate them. So here's what I'm going to do. Remember, the area of the print is x times y equals 24. Let's solve for y. Divide the x away. And y is going to equal 24 divided by x. And substitute that in to here. Let's do some substitution. So the area of the paper is going to equal x plus 3 times 24 over x plus 2. And that's what I'll derive. Now it's all in terms of x's. Before I start doing a lot of work, it's a big product rule thing. You might find that foiling it out, multiplying the x by each of these and the 3 by each of these is easier. That's what I'm going to do. Area equals x times this fraction is going to cancel the x's, so it's just 24, plus x times 2 is 2x, plus 3 times 24, that's 72 over x, plus 3 times 2 is 6. And then to clean this up, I'll combine 24 and 6 to make that 30, plus 2x, plus I'll make this 72x to the negative 1 power, so it looks a little bit better. Now let's just power rule this thing. So a prime is going to be, the derivative of 30 is 0, 2x is 2, minus 72x to the negative 2 power. There's our derivative. Now set it equal to 0, and we have 2 minus 72 all over x squared equals 0. I'm going to get rid of that negative power. And so this is the thing we're going to solve. We're looking for critical numbers. First of all, if x equals 0, you're going to have d and e in this fraction. So that's a critical number. That's one answer. And then to solve it, you might find flipping the fraction to the other side, so it's a positive 72 over x squared equals 2. That might be easier. Move the x squared up. 72 equals 2x squared. Divide the 2 away from both sides. So divide 72 in half, and that's 36 equals x squared. And then take the square root of both sides. So square root, x is going to equal plus or minus 6. We get three answers, three possible answers, 0 and positive negative 6. Those are what it'll be we're going to put those on our sign chart. Logically, we know that x really can't be a distance of negative 6 inches or 0 inches, because if it was, remember this is what x is. If this was 0 or negative 6, we wouldn't have paper. So we only really see one possible solution, positive 6. So why don't we just focus in on that with our sign chart. When we build it, I'll put 6 on here, and I won't even worry about negative 6 or 0. Maybe I'll put 0 in the end and put a box around it so I don't forget it is a critical number. I just don't think it's a solution. And then I'm going to label this the sign of A prime and the behavior of A. Got to get those labels on there. And we're going to pick numbers in between, so like we could pick like 1 and 10, and we're going to plug them into A prime. We're going to plug them into our derivative, which conveniently is right here. So I'm going to plug them into that thing to figure out positive or negative. If I plug 1 into there, 2 minus 72 over 1 squared, that's totally going to be negative, so I'll put a little negative sign up there. It means it's decreasing. And if I plugged in like 10, 2 minus 72 over 10 squared, that's going to be positive, so it's going to be increasing. So negative, positive, that makes this a minimum value. Decreasing, increasing. So definitely a min on that thing. Which means 6 has got to be our answer. It's the least amount of paper. So when x equals 6, we have the least amount of paper being used. Now let's go read the final question. The final question said, what should the dimensions of the page be so that the least amount of paper is used? So the dimensions of the page, the entire page. So remember the dimensions were x plus 3 and y plus 2. So we should probably go and figure that out. So here's what we know. Let's go down here. If x is 6, remember x times y had to equal 24. So if we have 6 times y equals 24, y has to equal 4. So x and y are these dimensions. Now the entire page of that paper had a dimension of x plus 3 and y plus 2. So if x is 6, we're going to do 6 plus 3 is the length of the page, and if y is 4, 4 plus 2 is the width of the page. So I'm going to get 9 and 6. So this page is 9 inches by 6 inches in dimensions. So that's my length and my width of my paper, 9 by 6. And I get my final answer. So this one's going to help you on the homework. I think it's problem number 2, if you look in the homework, is really close to this one, almost identical. So see if you can use this problem to kind of help you out, and we'll check answers in the morning.